First, we start with the compressed gas cylinder. Here we have an H cylinder, which is what is available at Pierce College. Then the knob, which is labeled E, is opened by turning it to the left. Then the oxygen flows to the pressure-reducing valve, labeled as B. It reduces the pressure of oxygen from 2,220 to 50 psi. This is a separate device that is added to the H tank. Then the tank pressure gauge, labeled C, is connected to the pressure regulator and indicates the pressure of the remaining gas in the tank. Next is the line pressure gauge, labeled D, which indicates the pressure in the intermediate pressure gas lines between the pressure reducing valve and the flow meter. First, we have a general overview of what an anesthetic machine looks like. We have the flow meter to the left, which measures the flow of gas to pass in the vaporizer, as well to further reduce the pressure of gas leaving the intermediate pressure line from 50 psi to 15 psi, which is slightly higher than the osmotic pressure we normally breathe. When the valve knob is turned in a counterclockwise motion, oxygen enters from the bottom of the gas column and exits at the top, pushing the ball indicator within the column. The oxygen flow in liters. The oxygen is measured in liters per minute and is indicated by viewing the ball at the widest part, the middle. Then it is connected to the oxygen flush valve, which allows oxygen to bypass the flow meter and vaporizer and enters into the system at 40 to 70 liters per minute. It is designed to allow the anesthesia circuit to be filled with anesthetic-free oxygen very quickly. Then, as we move past, we can see our vaporizer, which is isoflurane. Oxygen then enters through the inlet port to the vaporizer and will then be mixed with a set amount of anesthetic vapor and come out with a mixture of oxygen and isoflurane anesthetic at the outlet port. The outlet port then contains a tubing, which then connects to the fresh gas inlet, which contains oxygen and anesthetic gas. Then at the very top of the machine, as you can see, we have two valves. We have our inhalation unidirectional valve and our exhalation unidirectional valve. Our inhalation unidirectional valve is what is connected from the fresh gas inlet. Our inhalation unidirectional valve is what directs the gas flow towards the patient upon inspiration, and our unidirectional exhalation valve is what directs the flow from the patient upon exhalation. Then, to the right of the exhalation unidirectional valve, we have the carbon dioxide absorbing canister. It contains calcium hydroxide, which combines with carbon dioxide exhaled from the patient and yields water from a chemical reaction, heat, and calcium carbonate, which is also known as limestone. We want to change the granules at least every 8 hours of anesthesia. Evidence of exhalation of the granules is a color change from white to a purple-blue, but it can then turn back to white. Then to the right, we see a bag hanging. That is the reservoir bag, which allows for controlled ventilation, and they allow us to better assess the respiratory rate and the tidal volume. Now above the carbon dioxide canister, there is the pressure monitor, which indicates the pressure of the gases that are within the breathing system and is going to be expressed usually as centimeters of water or milliliters of mercury. Then our pop-off valve, which vents out gas to the scavenger system, is located between the expiratory unidirectional valve and the carbon dioxide absorber canister, which prevents inadvertent buildup of pressure within the system. The purpose of the scavenging system is to eliminate excess anesthetic gases from the work area to minimize breathing by the personnel. The flow into the scavenger system is dictated by the pop-off valve in the rebreathing system and the valves in the reservoir bag in the non-rebreathing system. Our scavenger system at Pierce has the F-air canister, which is an activated charcoal canister, and is replaced after 8 to 12 hours of use or if there has been a weight gain of 50 grams. The F-air canister contains activated charcoal and absorbs waste halogenated anesthetic gases, and O2 and carbon dioxide are vented out of the bottom must be elevated off of the surface or floor as gas is vented out of the bottom of the canister. Now we're going to set up for the rebreathing circuit. I'm checking that our oxygen supply is then connected to our flow meter, and our flow meter is at 0, which also connects to the oxygen flush valve. Now I'm connecting the inlet port for the oxygen, and now I'm connecting for the outlet port, which has oxygen and anesthetic. The tube then connects to the fresh gas inlet, which is then connected to the inspiratory unidirectional valve. Now I'm connecting the inhalation tube, which connects to the inhalation unidirectional valve, and the exhalation tube to the unidirectional exhalation valve. Now the reservoir bag is being connected. There will be a flow of oxygen and anesthetics in the inhalation tube and carbon dioxide and anesthetics through the exhalation tube. Now oxygen, carbon dioxide, and the anesthetics will flow through the pop-off valve to the scavenging system. Now we'll be completing a pressure check. We're checking that we have our inhalation and exhalation tubes connected. Our oxygen is connected to the flow meter and the oxygen valve. That is what we'll be mainly using, the oxygen valve. And we're going to make sure that we have our reservoir bag. And we're making sure that everything is secure and tight and everything is connected. We're closing off the pop-off valve to the right, righty-tighty, lefty-loosey. Now I'm connecting the Y tube and placing it into the palm of my hand. Now I'm going to be watching the pressure manometer. Now I'm pushing the oxygen valve so that way I can have oxygen flow and fill the reservoir bag, and I'm waiting for that pressure manometer to reach 20 centimeters. Then I count for 10 seconds to make sure that there are no leaks within the system. Now I release the pop-off valve, and as you can see, the reservoir bag is now deflating. So the system is good to go. There were no leaks. Now I'm checking for the non-rebreathing circuit. Checking that the oxygen is then connected to the flow meter. We have our flow meter. Then I'm making sure that we connect to the inlet port of the vaporizer. Then I'm going to connect our non-rebreathing system to the outlet port, so that way we have oxygen and anesthetics flowing through the connector, which will flow through the reservoir bag and then connects to the scavenging system, which contains carbon dioxide, anesthetics, and oxygen. Now we'll be pressure checking for non-rebreathing. We have our oxygen connected to the flow meter. We're making sure that our outlet is connected, and our outlet is connected to our non-rebreathing system. I have my hand placed against the connector, and now there's also a pop-off valve on the actual reservoir bag. Then I turn the flow meter up all the way, and then I let the flow of oxygen flow through the reservoir bag completely till it's full. Then I turn off the flow meter, and then I wait 10 seconds while I'm still holding the pop-off valve. Making sure that there are no leaks in the system. Once the 10 seconds are up, I release my finger off, and then I release the pressure from the system, which then flows through the air canister.